Bismillahirrahmanirrahim. Assalamu alaikum. I am Fakhr Lodi and this is our 19th lecture of Formal Methods for Software Engineering. In the previous lectures, we have been discussing design by contract. As we discussed earlier, and we saw there that this design by contract was proposed and invented by Burton Meyer based upon Horst triple. So it is a semi-formal kind of a tool or a notation or a methodology through which we can define certain types of contracts, and the contract is the pre and post condition and the invariant condition on our classes, and with the help of that design by contract, we shift the responsibility to the client side as well as to the server side. So सारी की सारी responsibility जो थी वो server side से हम लेके कुछ responsibility हमने client side की तरफ shift कर दी, और इससे server side का code जो है will become easier and cleaner so to speak, और उसमें बहुत सारा जो काम जो हम अदरवाइज करते हैं कोड को रोबस्ट बनाने के लिए वो आपको करने की ज़रूरत नहीं पड़ेगी. डिज़ाइन बाय कॉन्ट्रैक्ट की एक इम्प्लीमेंटेशन हमने जे कॉन्ट्रैक्टर की सूरत में देखी. जे कॉन्ट्रैक्टर इज़ अ टूल फॉर जावा. it is written in pure Java language and it can be used with any Java program, and we saw how easily we can use this J contractor, and it is a wonderful tool for at the time of development and for debugging. इस सिलसिले में जो चीज़ दोबारा मैं ज़हन नशीन आपके करवाना चाह रहा हूँ कि ऑल्दो इसकी बेसिस सारी वो होर लॉजिक में है, लेकिन जो वेरिफिकेशन की थ्योरी जो है वो अभी हमने उसके ऊपर मेथड्स इतने ज़्यादा डेवलप नहीं हम कर पाए जो उसको ऑटोमेटिकली उसको वेरीफाई कर सकें आपके कोड को. सो दिस इज़ अ सेमी फॉर्मल काइंड ऑफ अ थिंग दैट वी राइट दिस कॉन्ट्रैक्ट इन द फॉर्म ऑफ प्री एंड पोस्ट कंडीशंस, and we make sure that the contract is not violated at runtime. So this is kind of a runtime assertion check there. So semi-formal mechanism hai. It is not completely formal, but it is an application of the formal methods, and which is becoming a mainstream kind of application. आज उसी सिलसिले को हम आगे बढ़ाएंगे और देखेंगे कि यही डिज़ाइन बाय कॉन्ट्रैक्ट इसी कॉन्सेप्ट को आगे लेके मॉडल जहाँ पर हम बनाते हैं, ऑब्जेक्ट ओरिएंटेड मॉडल्स बनाते हैं, उन मॉडल्स के साथ यही डिज़ाइन बाय कॉन्ट्रैक्ट्स और इससे मिलते जुलते कॉन्सेप्ट्स को शामिल कर दिया गया है UML में, और नाउ इट इज़ पार्ट ऑफ अ UML. This concept that we shall study today, or this new methodology which is now part of the UML, is known as Object Constraint Language, or OCL. OCL was developed at IBM, and as I have already mentioned, it has now become part of UML standard, has been adopted by OMG, and now you can use it, and there are number of tools freely available where you can define constraints on your UML models, और उससे आप बहुत कुछ काम कर सकते हैं, और वही बहुत सारे इफ़ेक्ट आप हासिल कर सकते हैं जो हम डिज़ाइन बाय कॉन्ट्रैक्ट के केस में हम ऑलरेडी देख चुके थे. सो दिस ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज मैं यहाँ पर इसलिए जिक्र उसका करना चाह रहा हूँ क्योंकि मेरे ख्याल में दिस इज़ बिकमिंग अ मेन स्ट्रीम टूल, एंड इट इज़ अ वेरी यूजफुल टूल फॉर कंपोनेंट डेवलपमेंट. और इसकी क्या वजह है? बिकॉज वी वांट टू हैव कंपोनेंट्स ऑफ हाई क्वालिटी reusable components of high quality. So this object constraint language would help us hopefully in developing those components. Although this mechanism has been there for quite some time, but yeah, aista aista it is getting popularity or gaining popularity. So ये object constraint language है क्या चीज? It is, as I mentioned earlier, is an extension of design by contract. वही असूल, वही मैकेनिज्म, वही चीज़ है, उससे मिलती जुलती है, कुछ नई चीज़ें भी इसमें हैं which are applicable on to UML models, और मैं उसका जिक्र करूंगा कि ये किस तरीके से अप्लाई होते हैं और इसका क्या फ़ायदा होता है, and we shall see few examples of those. So this design by contract basically is a query language. It is a formal language in which you specify constraints on objects, classes, attributes, functions, their associations, and we specify, for example, if class A is associated with class B, we also specify some kind of constraint. We can specify some kind of constraint on that link between those two classes. So it is on the attributes, it is on the methods or functions, or the relationships between classes. All those different things could be annotated with the help of these constraints, and these constraints can be checked with the help of tools. There are tools available. आपको पता है कि UML में there are tools available where you give the UML model and it will generate lots of code for you, or essentially the basic code. So उसके साथ साथ आपको ये constraints checking के भी facility available हो जाती है. जब code generate होता है तो इस तरह के mechanisms भी आपको मिल जाते हैं where you can have something similar to आपके design by contract, और जहाँ पर आपने constraints को impose करना है, उन constraints का check in your code. So these kind of tools are also available. As I mentioned earlier, that this is a query language. Query language means that this language defines constraints. So when those constraints are checked, or when this model is executed, it does not change the state. It only gives you certain information about the state. So we have all those different things, the invariants, the precondition, the postconditions. We have a new concept here called a guard, which is very, very similar to the other constraints that we have already mentioned. And like I said, these constraints can be applicable on almost everywhere in a UML model. So ये इसमें एक important और interesting चीज़ है कि UML मॉडल में जो भी आपके मुख्तलिफ components होते हैं, UML मॉडल में we have the classes, we have their attributes, we have their methods, we have their relationships. All of those could be given some kind of formal semantics through this constraint mechanism, and that is very helpful in defining a better and more complete system with better semantics there. So उसमें गलती करने की और misunderstanding के chances कम हो जाते हैं. So मैं ज़रा थोड़ी सी OCL पे थोड़ी सी बात करूँगा. Let me go to a slide and show you a few definitions and few things, and then we'll come back and discuss what does that mean. Expressions in OCL can be used in a number of places in a UML model. It can be used to specify the initial value of an attribute or association, can be used to specify the derivation rule for an attribute or association end, to specify the body of an operation, to indicate an instance in a dynamic diagram, to indicate a condition in a dynamic diagram, to indicate actual parameter values in a dynamic diagram. यहाँ पर कुछ चीज़ें जो मैं पहले जिक्र नहीं किया, नई हमने जिक्र किया है. As I already mentioned कि constraints जो हैं OCL language itself और इसका use जो है, that is we use this language to define the constraints. These constraints can be defined anywhere in the UML model, not just the static model but also the dynamic model also. So इसकी एक लंबी चौड़ी specification है. We won't have time to go deeper into OCL and look at more complex scenarios, but the point really is that we can use it not in the static model, not just in the static model, but also in the dynamic model as well. And we can specify different properties like I mentioned, to the extent that we can talk about the input variables in the dynamic model, and then we can specify certain kind of constraints on those, and that will help us. What kind of constraints are these? मैं अभी आगे चल के examples की मदद से आपको explain करूँगा, and then you will appreciate कि ये कितना powerful और कितना useful tool है. Unfortunately, many people are not aware of this tool. So, but those who have used this tool, they like it very much. Let me go back to slide once again and then discuss a few more definitions. There are 4 types of constraints, as I already mentioned. These constraints are an invariant, a precondition, a postcondition, and a guard, which is a constraint that must be true before a state transition fires. So, इसमें जो पहली 3 चीज़ें हैं, that is the invariant, precondition and a postcondition, ये तो वैसी ही हैं जैसे कि हम इससे पहले डिज़ाइन बाय कॉन्ट्रैक्ट में देख चुके हैं. बेसिकली वही कॉन्सेप्ट है. प्रीकंडीशन और पोस्ट कंडीशन एक मेथड पे एप्लीकेबल होती हैं, और इनवेरिएंट जो है वो ओवरऑल क्लास पे एप्लीकेबल होता है, बट you can also specify invariants on certain attributes and so on and so forth. So ये तो वही concepts हैं. जो guard का concept है, this is a new concept. Remember, अभी थोड़ी देर पहले I mentioned that this object constraint language जो है, it also can be used with the dynamic model in the UML. So UML is not just about static model. There are many different types of models, और उनमें आपके dynamic models भी होते हैं. And we have state transition diagrams also. That is also one of the models that we can have in our UML. Usually state transition diagram बनाने की ज़रूरत नहीं पड़ती, but in some complex scenarios आपको state transition diagram बनाने की ज़रूरत पड़ सकती है. That helps actually in making a better model and understanding the system. So ये जो guard जो है, ये इस तरह के मॉडल्स में एप्लीकेबल होता है, and we say कि a transition cannot fire until and unless a guard is true. So ये जो है हमारा जो चौथा एक इसमें कंपोनेंट है ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज का. There is another very important concept in OCL, and that is called a context. The context definition of an OCL expression specifies the model entity for which the OCL expression is defined. Usually this is a class, interface, data type, or component. In terms of the UML standard, this is called classifier. Sometimes the model entity is an operation or attribute, and rarely it is an instance. So it is always a specific element of the model, usually defined in a UML diagram. The element is called the context of the expression. Here what we are saying is, we specify this expression which is a constraint, some kind of a constraint. ना ये कंस्ट्रेंट किस चीज पे एप्लीकेबल है, जिस चीज पे ये कंस्ट्रेंट एप्लीकेबल है, दैट इज द कॉन्टेक्स्ट ऑफ दैट कंस्ट्रेंट. सो कॉन्टेक्स्ट के बगैर कंस्ट्रेंट्स का और एक्सप्रेशंस का मतलब नहीं है. सो व्हाट हैपन्स इज we have a UML model, and in the UML model we will have different components there, and with those components we will add these constraints in the form of expressions, and we will link these expressions with those attribute or a method or a class or what have you, and that will be the context. We will say that this is the context of this particular thing. So we kind of annotate this thing. It is kind of a note. अगर UML को आपने इस्तेमाल किया हो, ज़रा डिटेल में देखा हो, तो आप UML में आप इनफॉर्मल नोट्स भी लिख सकते हैं. ये ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज जो है, ये बिल्कुल एक तरह से एक नोट ही है, बट दिस टाइम दिस इज़ अ फॉर्मल नोट, दिस इज़ नॉट एन इनफॉर्मल नोट. सो ये आप जब आप कहते हैं कि ये कंस्ट्रेंट है, तो इट बिकम्स फॉर्मल. इसकी कुछ और ज़रा हम डेफिनेशंस पे और कुछ और चीज़ों को हम देखते हैं बिफोर वी कैन एक्चुअली look at an example. Next to the context, it is important to know the contextual type of an expression. The contextual type is the type of the context or of its container. It is important because OCL expressions are evaluated for a single object, which is always an instance of the contextual type. So ये जो हमारे OCL के expressions जो हैं, they would have a type associated with them also, and that type is related with the context also. So जो contextual type जो है, ये भी important चीज़ है to note and remember. Now let us look at what are these constraints. I'll just show you a model, a very simple model, and then show you different types of constraints and the context, and then we will talk about more in terms of these models and the OCL, where it is useful and how can we make the model more meaningful and have more semantics into it. So here we are. We have a very simple model in which we have two classes. We have a loyalty account and we have a transaction. So these are the two classes. So a customer has an account, and under one account there may be a number of transactions. So we have one to many, zero or more. This is the cardinality. So you can, as you already know, that you can specify the cardinality. So the basic idea here is that whenever a transaction takes place, a customer earns some kind of points. For example, if you are using, let's say, a credit card, so every time you make a transaction with that credit card, so uske against तकरीबन बहुत सारे जो क्रेडिट कार्ड के जो मुख्तलिफ बैंक्स जो इशू कर रहे हैं, they give you certain points and you can accumulate those points and then use those points to do number of things. For example, have a free lunch, or get some gifts, or so and so forth. So basically that is the idea, that each time there is a transaction, some points are earned, and those points are actually accumulated into this account and you get it here. So the loyalty account has these two parameters, these two attributes, the points and the number, and it has these three methods: earn points, burn points, use those points, and is empty is, as the name suggests, this is a Boolean kind of a method, and the transaction, it is associated with this loyalty account. So where are our constraints? So let us look at the first one. Here, what we have done is we have added a note, and this note, with the help of this dotted line, we have created a context here, and we are saying that this note, actually this is not a note, this is a formal note, this is a constraint, is associated, and the context is the points, and what we are saying is that it is initialized to be equal to 0. So this is the first thing. Now here, previous case we had it with the attribute. Now we have it with a method. Here in this case, we are talking about the body of this method is empty, and we say that it is empty means that the points is equal to 0. So this is, again, with the help of this dotted line, we have linked these two, and we say that the context of this constraint is this method here. Now this is another very interesting thing, and we shall see more useful examples of this. We are saying that a loyalty account can be associated with 0 or more transactions. So here, once again, we say that this is a transaction, this is a set, a collection, and this set is initially empty. So we have now put a constraint on the cardinality association, cardinality of the association, and we are saying that, this association means that, initially we have an empty set here, that is the number of transactions associated with the loyalty account are 0. Now here is our famous old precondition. Now here we have associated this precondition with this method earn, and we are saying in this particular case that this I is greater than 0, and I is the value that is input. So we are saying, that is number of points that are to be earned, they are greater than 0. You cannot pass a number which is 0 or a negative number here. So must be a positive number here. So this is a precondition that we have. And finally, we have associated a constraint with this class loyalty account, and we say that this is an invariant condition. And forget about the syntax here for the time being, but what we are essentially saying is that the transaction.card.owner size is equal to 1. What does that mean? For the time being, you don't need to worry about that. Maybe when we go into that syntax and more detail of what this method size is and so on and so forth. But point here is, the idea is that we are associating an invariant with the class. So the invariant here is just like the invariant that we saw in the case of design by contract. So here, you saw that this object constraint language provides us the tools and facilities where we can define the constraints on not just a single class, and the constraint is limited to that single class. We are talking about these constraints. We are saying not just the pre and post conditions. We are not just talking about the invariant condition, but we are talking about attributes. We are talking about the associations and the linkages between different classes also, and we can define constraints onto those as well. So this is a very useful and powerful concept, and we shall see how we can use these to define and specify the semantics of our models. Note one thing here, in the object model, जो नोट्स लिखने का मकसद था, जो नोट्स का एक मैकेनिज्म दिया गया था इन GUML, उसका मतलब यही था कि otherwise, you know, if you have just the two classes, and the two classes are, for example, here we have the loyalty account and we have the transactions, and we have an association between them, one-to-many association. All it is showing and telling you that these are the two classes and this is how they are related. And without the help of these constraints or other nodes, nothing much is known, and you know, obviously you will have to understand the domain to really understand what does that mean. So here मॉडल के बीच में ही जहां पर ना सिर्फ हम उसके क्लासेस और उनकी रिलेशनशिप्स को हम शो कर रहे हैं, यहाँ पर उसके एट्रीब्यूट्स, मेथड्स एंड रिलेशनशिप्स, तीनों चीज़ों को शो कर रहे हैं जो कि अदरवाइज यूएमएल में होता है, बट ऑल्सो semantics. So now we are giving meanings here, and we are adding meanings and semantics in the model. So इससे पहले जो मॉडल जो एक sort of dumb picture थी, mute picture थी, and it just had, you know, classes and their relationships, classes with attributes and methods and their relationships. But it did not talk about, you know, how these classes are being used, how these relationships are being used, and what are the methods, what are the constraints, under which conditions these attributes and these methods should be used, and so on and so forth. Now all that information is being put into the model, और जो भी इसको देख रहा है और जो इसको पढ़ रहा है, you know, will get more information about the system. So ये तो एक उसका documentation का aspect हो गया कि, you know, it gives better documentation, precise documentation. But on the other hand, मैं इससे पहले जिस तरीके से जिक्र कर चुका हूं कि ये जो मॉडल्स जो हैं, now we have case tools जो ये मॉडल्स को लेके they can generate a lot of code for you also. And when the constraints are there, these tools which generate code, they can generate code to ensure that those constraints are fulfilled. Also, at the system level, you know, there are model checking tools which check for those constraints and which see whether the constraints are consistent with each other. The whole model is consistent or not. तो ये सारी की सारी चीजें अब आपको अवेलेबल हो जाएंगी. Now let us look at these constraints in more detail, and with the help of examples एक एक करके हम मुख्तलिफ चीज़ों को देखते हैं, and then we see कि इसका क्या फ़ायदा हो सकता है. So the first thing is invariants on attributes. This is the simplest constraint, and that is invariant on attribute. Now let us suppose our model contains a class customer with an attribute age. Then the following constraint restricts the value of the attribute. We say context is the customer and it is an invariant, and we say age is greater than equal to 18. Now here what we are saying is, okay, let us just assume that, you know, the card holder is only somebody who has a national ID card here, somebody who is older than 18 years. So you cannot give this thing to children, and children cannot use it, and so on and so forth. So there is a restriction on this thing. So what we do is we put this on the age, and the constraint on the age is greater than equal to 18, and this is an invariant condition on the attribute here. And, you know, obviously all these invariants will be ended, but, you know, you can talk about individual attributes one at a time also, or you could have more than just one attribute, and you can use the conjunction and disjunction and those operators to build more complex kind of invariants, but those would be probably at the class level, not on the individual attribute level. So एक attribute पे जो सबसे simplest आपके पास चीज है, you can have these kind of invariant conditions defined for those. Next is invariance on associations. So one way also put constraints on associated objects. Let us assume that in our model we have the class customer which has an association to class salesperson, the role name sales rep, and the multiplicity 1. Then the following constraint restricts the value of the attribute knowledge level of the associated instance of the salesperson, and we say context customer. So this is the context which we are using. It is an invariant. We say sales rep dot knowledge level is greater than equal to 5. Now this is again a very interesting scenario. यहाँ पर हम ये कह रहे हैं कि there are these two classes who are related through some kind of association here. And we are putting the constraint on the association. And for example, if this class, that is the salesperson, is used somewhere else on with some other class and it is associated and linked with some other class, this particular constraint will not be applicable there. So we are saying in this particular case, the sales rep, the knowledge level for the sales rep for this particular case where it is associated with, here we are saying all those instances which are associated with this class, for them the knowledge level must be greater than equal to 5. Now this is not applicable to the entire set of objects. ये possible है, आपको मालूम है कि यानी कि एक class can be linked with many other classes, and in those cases different instances may be linked with or associated or used with different instances of different classes. So we are not saying that every instance of a class is associated with every other instance of the class. So जो object relationship की बात कर रहे हैं, class relationship की यहाँ पर बात नहीं कर रहे हैं. So हम उन तमाम object instances की यहाँ पर बात कर रहे हैं, and we are putting a constraint on those object instances which are related with the class that this class is associated with, and on the association we are specifying that this means कि ये इसके इस particular attribute की value इस तरीके से होनी चाहिए. Again, a very useful, very important concept, and it gives a lot of flexibility to you, and that means कि एक केस में आपका कुछ वैल्यूज हो सकती हैं, दूसरे केस में आपकी कुछ और वैल्यूज हो सकती हैं, और ये सब के सब पे अगर आप अप्लाई नहीं करना चाहते, पिछला केस जो हमने देखा था वो एट्रीब्यूट की वैल्यू ग्रेटर देन इक्वल टू 18 जो एज का एट्रीब्यूट था, इसका मतलब ये है कि तमाम इंस्टेंसेस पे वो एप्लीकेबल होगा. बट इन दिस पर्टिकुलर केस ओनली दोज इंस्टेंसेस व्हिच आर linked here through this association. Then we have collection of objects. In most of the cases, the multiplicity of an association is not 1, but more than 1. So evaluating a constraint in these cases will result in a collection of instances of the associated class. Constraints can be put on either the collection itself, for example, limiting the size, or on the elements of the collection. So here is an example. Suppose in our model, the association between the salesperson and the customer has role name clients and multiplicity 1 or more on the side of the customer class. Then we might restrict this relationship by the following constraint. We have context salesperson. It is an invariant, and we say clients size is less than equal to 100, and clients for all customers age is greater than equal to 40. Now here once again see what we have done. हमने अब एसोसिएशन पे वी सेड कि जी इट इज वन और मोर, लेकिन कितना? सो वी आर सेइंग इट कैन नॉट बी मोर देन 100. सो जो स्टार जो है, जो मेनी की है, सो वी आर रिस्ट्रिक्टिंग दैट, एंड वी आर ऑल्सो we may want to add another constraint, and we are adding that constraint here, and we say for all the instances here the age is going to be greater than equal to 40. So मेरे let's say जो इस particular case में जो सेल्स पर्सन है उसकी एज 40 से कम नहीं होनी चाहिए. Maybe we need some kind of maturity there. Then we have the pre and post conditions. In the pre and post conditions, the parameters of the operations may be used. Furthermore, there is a special keyword result which denotes the return value of the operation, and it can be used in the post condition only, just like in design by contract. So here is one example, and it is very, very similar. So we have an example. We added an operation sell to the salesperson class. So we say context is the salesperson and the operation is sell. The parameters are item things. It is returning a real number. The precondition is sellable items includes, so this is the item. And the post condition is not self-sellable items includes item and result is equal to item dot price. So this pre and post condition बिल्कुल वही concept है जो design by contract का concept है. Only thing is the notation is slightly different. I am not going to get into the syntax and the notation at this point in time because वो आप you can read the reference manual और उसमें बहुत सारी details हैं. वो शायद इस वक्त हमारे पास उतनी detail में जाने का मौका नहीं है. But idea is the same and it uses the same kind of mechanism जो result हमने design by contract में देखा था, जो हम post condition में हम use कर सकते हैं, जो उसकी return value है. So बिल्कुल उसी से मिलता जुलता यहाँ पर भी concept है. Then we have the derivation rules. Models often define derived attributes and associations. A derived element does not stand alone. The value of a derived element must always be determined from other base values of the model. Omitting the way to derive the element value results in an incomplete model. Using OCL, the derivation can be expressed in a derivation rule, and here is an example. The value of a derived element used services is defined to be all services that have generated transactions on the account. So this is how we write it. We say context, loyalty account, use services. Now this is a derived from loyalty account, set services, and we derive transactions service as set. Now here, once again, as we know that in object-oriented model and object-oriented programming, we can have derived classes also. So we have the base class and we have a derived class. So जब आपने base class पे कुछ rules specify किए हुए हैं, वो derived class पे already वो लग जाएंगे, जिस तरीके से हम design by contract में देख चुके हैं. But you can also add new things, and then you can link it with the base class also. और बेस क्लास में जो कुछ आपने चीज़ें की हुई हैं उसके साथ आप कर सकते हैं. सो यहाँ पर जो डिराइव्ड क्लास की जो लिंक है बेस क्लास के साथ, वो यहाँ पर शो हो रहा है. एंड ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज OCL में यू कैन डू दिस ऑल्सो. देन वी हैव द इनिशियल वैल्यूज. In the model information, the initial value of an attribute or association role can be specified by an OCL expression. Here is this example. The initial value for the attribute points is 0, and the association end transaction, it is an empty set. So we have the context loyalty account points integer, init is equal to 0, and loyalty account transaction set transaction init set empty set. ये मैं आपको पहले डायग्राम जो दिखाई थी उसमें भी हमने ये इनिशियल वैल्यूज़ पे बात की थी जो हम पॉइंट्स की इनिशियल वैल्यू वो 0 और वो ट्रांजैक्शंस और जो सेट जो कलेक्शन बनती है वी सेट कि दैट सेट इज एम्प्टी सेट. सो वी कैन स्पेसिफाई द इनिशियल वैल्यूज ऑल्सो. सो वंस अगेन आप देखिए कि कितना इसमें चीज़ें हमारे पास शामिल हैं और कितना आसानी से हम बहुत सारी चीज़ें डिफाइन हम कर पा रहे हैं इसमें. हियर यू मस्ट note the difference between an initial value and the derivation rule. A derivation rule states an invariant. The derived element should always have the same value that the rule expresses. An initial value, however, must hold only at the moment when the contextual instance is created. After the moment, the attribute may have a different value at any point in time. Although this thing is obvious, but I wanted to make it explicit and wanted you to note it, that the initial value is not an invariant condition. Initial value is applicable when the instance is created. At that time we are saying this is the initial value of an attribute or a association or what have you. An invariant condition is an invariant condition. So it should be there, it should be fulfilled no matter what. जितने मर्जी आप उसके इंस्टेंसेस बना लें, जितने मर्जी आप ट्रांजैक्शंस कर लें, जितनी मर्जी मेथड कॉल्स आप उसकी हो जाएं, the invariant condition must always be fulfilled. ये डिज़ाइन बाय कॉन्ट्रैक्ट में हम इसको बहुत ज़्यादा डिटेल में कर चुके हैं, लेकिन वहाँ पर इनिशियल वैल्यू को डिफाइन करने का हमारे पास मैकेनिज्म नहीं था. यहाँ पर वी कैन ऑल्सो डिफाइन द इनिशियल वैल्यू. Then we can have the body of query operations. The class diagram can introduce a number of query operations. Query operations are operations that have no side effects, that is, do not change the state of any instance in the system. Execution of a query operation results in a value or set of values without any alteration in the state of the system. Query operations can be introduced in the class diagram, but can only be fully defined by specifying the results of the operation. Using OCL, the result can be given in a single expression called the body expression. So here is an example. We have the context loyalty account and we have the method get customer name. It returns a string and the body is membership.card.owner.name. So here what we are doing is, हमने ना सिर्फ एक मेथड की प्री एंड पोस्ट कंडीशंस हम डिफाइन कर रहे हैं जो इससे पहले हम देख चुके हैं, बट वी कैन ऑल्सो टॉक अबाउट द बॉडी कि ये इसमें है क्या, कि इन दिस पर्टिकुलर केस क्या चीज ये रिटर्न करेगा. एंड दैट इज बेसिकली almost in many cases may be the complete definition of the method itself. And as you can see that if you have this kind of a constraint, when that model actually is the case tool uses that model, can generate the code for that specific language जिसके लिए आप कोड जनरेट कर रहे हैं. So यहाँ पर आपने कंस्ट्रेंट आपने डिफाइन कर दी. अब आप ये कह सकते हैं कि जो बॉडी जो है इसका मुझे क्या फ़ायदा है, मैंने ये बॉडी में कर दी, मैं वहाँ पर C++ के कोड में अगर ये चीज़ लिख दूंगा तो इतनी सी बात हो जाएगी. दो इसमें है कि अगर ये बॉडी बिल्कुल सिंपल सी है तो आपने यहीं पर लिख दी. और दूसरी इसमें इंपॉर्टेंट चीज़ ये है कि देन द केस टूल, अगर आप उसे कहेंगे कि C++ का कोड जनरेट करना है तो इट विल जनरेट कोड फॉर C++ और इट कुड जनरेट कोड फॉर जावा गिवन कि आपने उसका जावा का कोड करना है. सो ये इसमें मुख्तलिफ चीज़ें हैं जो हमें देखने की ज़रूरत पड़ेगी और इस पे हमें तवज्जो देने की ज़रूरत है. एंड फाइनली वी हैव ब्रोकन कंस्ट्रेंट्स. Evaluating constraints does not change any values in the system. A constraint states this should be so. If for a certain object the constraint is not true, in other words it is broken, then the only thing we can conclude is that the object is not correct. It does not conform to our specifications. Whether this is a fatal error or a minor mistake and what should be done to correct the situation is not expressed in the OCL. So here once again जिस तरीके से हम डिज़ाइन बाय कॉन्ट्रैक्ट के केस में हम दे चुके हैं कि अगर आपका कॉन्ट्रैक्ट फुलफिल नहीं होता इन दैट पर्टिकुलर केस, वो एक एक्सेप्शन रेज होती है रन टाइम पे। यहाँ पर भी जो आपके मॉडल चेकर्स जो हैं, when you apply that model checker, and there are tools available, you can build the model and then check the model. So you may find कि certain constraint is broken for whatever reason. हो सकता है कि एक जगह एक constraint आपने define की हो, दूसरी जगह कुछ हो, there is a conflict there, or for some other reason, it is not fulfilled. The model checker will tell you कि okay, there is some violation of the constraint. What does that mean? ये इस violation का क्या मतलब है? Now it is up to the model builder to decide and define what to do and correct the mistake. OCL और model checkers जो OCL पे build करके होते हैं, they will simply tell you कि there is some problem with the model, there is some problem with the constraint, there is some problem, some constraint is broken somewhere and it must be fixed. So ये एक ओवरव्यू एक तरह से डिज़ाइन बाय कॉन्ट्रैक्ट की इम्प्लीमेंटेशन इन द फॉर्म ऑफ ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज है। यहाँ पर हमने ये देखा कि इट इज़ एक्चुअली एन एक्सटेंशन ऑफ डिज़ाइन बाय कॉन्ट्रैक्ट, क्योंकि डिज़ाइन बाय कॉन्ट्रैक्ट एक क्लास के ऊपर लिमिटेड है उसके मेथड्स पे। It gives you the pre and post conditions on the methods, and it gives you a class invariant. But in the case of this object constraint language, it is much more than that. It is much more flexible. So it is not just limited to the class invariant and the method pre and post conditions, but also it covers the entire model. So not just the static model, but also the dynamic model. और इसमें यानी कि एट्रीब्यूट्स पे, उनकी क्लासेस की रिलेशनशिप्स पे, वो सब चीज़ों पे हमने देखा कि हम वी कैन डिफाइन कंस्ट्रेंट्स एंड वी कैन ऐड मीनिंग टू दोज लाइंस एंड सिंबल्स। और जो इससे पहले एक म्यूट सी चीज़ थी, अब उसके साथ मीनिंग्स एसोसिएट होने शुरू हो गए और उसके साथ एक डेफिनेशन एसोसिएट होनी शुरू हो गई। एंड इफ यू यूज दिस, यू कैन सी वेरी इजीली कि ये आपको बहुत ज़्यादा ये आपको हेल्प करता है। रिमेंबर कि अगर आपका डिज़ाइन अच्छा है, हमारी जो सॉफ्टवेयर इंजीनियरिंग में हम ये चीज़ जानते हैं कि जितना अर्ली स्टेजेस पे अगर आप किसी प्रॉब्लम को कैच कर लें, उतनी आपकी ओवरऑल कॉस्ट डेवलपमेंट की कम होगी, और जितना आप उसको लेट स्टेज पे प्रॉब्लम को कैच करेंगे, आपको यू विल हैव टू रीडू अ नंबर ऑफ थिंग्स। फॉर एग्जांपल, अगर टेस्टिंग पे पहुंच के आपको पता लगता है कि देयर वाज अ प्रॉब्लम, so you may have to change the design and then recode it and then retest it, and then so the cost really jumps. So जितने early आप इसको प्रॉब्लम को किसी को भी कैच कर लेंगे, उतनी उसकी कॉस्ट कम होगी। सो जितना आपका मॉडल कंप्लीट होगा, इसका मतलब ये है कि चांसेस आर यू कैन कैच द प्रॉब्लम अप देयर बहुत जल्दी। अगर वो आपको ये कंस्ट्रेंट्स वगैरह आपने वहाँ पर डाली हुई हैं, अगर किसी वजह से कोई चीज़ वायलेट हो रही है, जब आप मॉडल बिल्ड कर रहे हैं, एट दैट टाइम यू विल फाइंड एंड कैच द एरर एंड यू कैन करेक्ट इट। सो दैट मीन्स कि ओवरऑल आपकी डेवलपमेंट की कॉस्ट जो है इससे काफ़ी कम हो सकती है, एंड यू कैन बिल्ड मोर रोबस्ट सिस्टम्स विद द हेल्प ऑफ दीज थिंग्स। सो नॉट जस्ट डॉक्यूमेंटेशन, not just code generation, but also it gives you a lot of in terms of saving cost and increasing the overall productivity of the team. अगले लेक्चर में we shall continue this discussion and I'll show you more examples इंशाल्लाह। उस वक्त तक आप मुझे इजाज़त दीजिए। खुदा हाफिज़ और अस्सलाम वालेकुम।